All right, this note-taking guide today is for a Math for Life class. We're in the probability unit, and this is day 7. Today we're talking about understanding and creating graphical displays of data. So what we're going to do today is we're going to look at a whole bunch of different kinds of graphs, and we're going to just answer some questions about them. So this might be rather difficult to see on the video here, so refer to your note-taking guide to see the problems and the numbers on the sides of the graphs that we're looking at here. So, and then just, I know that mine is in color and yours is not, so let's just kind of make a couple of references here. Private is always going to be this first column of graphs that you have right here on your bar graph. The public will always be the second graph, so this one down here that's right next to that, and then the public in-state will always be the third one that's listed there. So just kind of keep that in mind so that we're not wondering which order they're going in. They're always in that same order. First bar graph is public or private, the second one is public out of state, and the third one is public in-state. So as we're looking at that data, just kind of keep that in mind. So number 1 says, in what year is private tuition $35,000? So again, remembering private is that first bar graph in each section. We want to know when it's up at $35,000. Well, the top one is $45,040, and then right here is $35,000. So in what year were we at $35,000? That is 2012 to 2013. So the answer to that would be the year of 2012 to 2013. Okay, we're going to just keep going on from there. Again, I apologize that your graph is hard to read on this. So number 2, it says, what is the cost of public out-of-state tuition in the 1997 to 1998 school year? So this time we're looking for public out-of-state tuition. So that would be the middle bar graph on each one of those that you're looking at. So public out-of-state tuition in the year 1997 to 1998, which is this first bar graph right here. So we're looking at the middle one on here, and we're just going to make our best guess as to how high we think that is. It's between 5,000 and 10,000 there, and I think that that's probably right around $8,000. So I'm going to guess $8,000 for my solution on number 2. On number 3 here, it says, in which school year is tuition lowest for private tuition? Remembering private is the very first bar graph that appears in each of your columns there. So private is in the lowest position right here in this year, which is the 1997 to 98 school year. All right, number 4 is a little bit more complicated. It says, what is the average rate of change or increase in public in-state tuition from 1997 to 2018? So the column that we're looking at this time, if we're looking at public in-state, that's column number 3. So the lowest ones that you see on each of these little columns here. If we want to find the average rate of change, it's really like finding the slope. We're finding the change in our y values over the change in our x values. So what I want to do is I want to look and I want to see what the tuition was here and what the tuition was here. And I'm going to subtract those values, and then I'm going to do the same thing with the years. So take the year from here and the year from here and subtract those in order to find pretty much the slope is what we're finding on this, to find the average rate of change or how much it changed per year from here to there. So that's kind of what we're looking at doing here. So what I want to do again is I want to just do what I would consider the slope formula. So how high is my tuition here? And I'm just going to do an estimate of what I think that is. I think that is right around $11,000. So that's the number I'm going to use, is $11,000. And then I'm going to go and I'm going to subtract from that the very first year of tuition in that time frame, which is right here. And my guess of what that is right around $3,000. So on the top, I'm going to subtract those two numbers, and then I need to do the same thing on the bottom for my years. So the last year that it's asked me to find the rate of change for was 2018. The starting year was 1997. Then I really can just punch that right into my calculator and have it give me the solution for that. And when I do that, I get, well, let me just do it real fast and see what I get. So I have 11,000 minus 3,000, and then on the bottom it's 2018 minus 1,997. And when I do that, I get 8,000 over 21, and then if I change that to how many dollars, we're looking at $380.95. So the tuition goes up $380.95 every year on average for the next year's tuition that's shown on our graph. Okay, number 5 asked me to do the exact same thing, but this time it asked me to do it for private tuition. Private tuition is those tuitions in that first column on every part of your graph. And again, it asked me to do it from 1997 to 2018. So I'm going to start with the 2018's tuition, and I estimate that to be at $42,000. So my first number is going to be $42,000. And then I'm going to subtract off that the first year tuition that they're asking me to look at there, and I'm going to estimate that at $16,000. Then I'm going to do my years on the bottom again. So I know the year they asked me to go from was 2018 all the way back down to 1997. I'm going to punch that in my calculator. Then I'm going to round that to the nearest dollar. And when I do that, I get an increase of $1,238.50 every year in the cost of private tuition, or an increase quite a bit higher than that of what it is for public in-state tuition. So that's how we answer the questions there on that first graph. That kind of a graph is called a bar graph. Bar graphs are most commonly used to compare data. So here we go with another example of how we can compare data. This graph is called a line graph. A line graph usually is just one set of data. You can use two sets of data on there and compare it, but for lots of line graphs, we're just using the one set and looking at how it changes over time. So looking at this graph here again, I apologize, it's hard to see on this video, so kind of just refer to your paper to see those numbers. But number 1 says, what is the value of Sarah's car? Is it decreasing or increasing? Well, this line over here, if we were to look at it as a line, we would say that that line has negative slope. And anything that has a negative slope is decreasing. So our answer on number 1 on this set of questions would be decreasing. Number 2 says, in the year 2003, what was the value of Sarah's car? So if you go over and look at the graph at 2003, you just need to go up and grab that number up there. And you can see that really clearly on your note-taking guide. That number is $19,700. So Sarah's car was worth $19,700 in 2003. Number 3 says, how much did the value of Sarah's car change between 2002 and 2006? So you're going to go over onto your chart and look at it at the value of the car for 2006, which is $10,000. You're going to go and look at the value of the car in 2002, which is $22,500. And we're just going to subtract those two numbers to find the value that her car changed in that amount of time. And when we do that, we get $12,500 as the difference. Number 4 is an average rate of change problem, which means we're going to be finding the slope like we did up on the problem up above. It says, what is the average rate of change in the value of Sarah's car from 2001 to 2007? So I'm going to go and grab those values. I like to start with the last number over here. So if I come over and I look at the last number on my graph, and it kind of got cut off on this video, you guys, I'm sorry about how poor this is. But if you look at it over there on your paper, it's $5,800. So I'm going to go $5,800 from the very last value her car had in 2007 to her starting value of her car. And her starting value of her car was $24,000. And then I'm going to have my years on the bottom. So it's 2007 minus 2001. When I punch that in my calculator, that's going to give me the average rate of change per year in her price. And I get that as a negative $3,033.33. Why would that be negative? Well, it would be negative because her car is depreciating or losing value. So I would expect that to be a negative number because that's what's happening. On the last problem, our numbers were always positive because it was an increase in tuition every year. This time it was a decrease in the car's value. All right, that last question there on number 5 says, what is the average rate of change in the value of Sarah's car from 2003 to 2006? So again, what I'm going to do is I'm going to go grab those values. If I go look at the value of her car in 2006, her car's value is $10,000. And if I go look at the value of her car in 2003, the value of her car is $19,700. Again, I'm going to subtract the years. So 2006 minus 2003. Let my calculator do the math on that. And when I do, I get a negative $3,233.33. So that's how we find the average rate of change between years on the value of her car, is to really just use the slope formula there. Okay, one more graph to look at here, and this time I think we're going to be drawing it ourselves. So we're going to compare some data here. It says, create a graphical representation of the data given. What is your favorite kind of book is what's in the chart. We have boys and we have girls. So we could do it a different couple of ways here. We could do a bar graph where we'd have boys in one, girls on the other, boys in one, girls on the other one, kind of like this, where we're doing a bar graph like this. Or if we wanted to on this, we could do 2 different line graphs. We could have maybe mystery, adventure, whatever our graph is doing, with a line for the girls and a line for the boys. You can decide which way you want to do it. I don't care how you do it. That's totally up to you. I think this time though, I'm going to choose to do a bar graph. I'm going to do mine like this. So I'm going to go and I'm going to number the sides over here, and I want to do it by, I think I'm just going to count by 5s. So I'm going to go 5, 10, 15, 20, 25, 30, 35, 40, and I think that's probably as high as I need to go. I didn't take a very good look at it, but I think that we don't go up to 40. We don't. And then over here, I'm just going to label this, and I think I'll probably just label every 2 spots with what we're doing here. And I'm just going to do M for mystery. So this is going to be my M column for mystery. So I am going to draw a column for the boys and a column for the girls. So the boys on the mystery, like 29 boys picked mysteries as their favorite book. So when I do this, I'm going to come and I'm going to go 29 for boys. So 29 is about right to there maybe on my bar graph. So I'm going to kind of just go up to here at 29, right below right here, and call that part of my graph. And I could even, if I wanted to, so that I knew the different boys on that the boys like the mysteries. Then I'm going to see if I can just change the color on this. so that I can get for girls. So let's try the girls now. On the girls for mystery books, it says 23. So I'm going to start at 0. And I'm going to go up to where 23 would be, which is about right here probably. And that's where I'm going to be at on my girls. Not doing a fabulous job at this, doing my bar graphs. But here's my girls, here's my boys. And that would be for mysteries. I'm going to go across my table here. I'm going to do adventures next. On the adventure books, boys are at 35. I think I might just draw them with this red pen this time. Go up to 35 and back down for boys. And then on the girls, the adventure is at 28. So I'm going to come up to 28, close to 28 where I think that's going to be. And then go like that again. So again, there's my boys, and there's my girls. I'm going to move on next to my science fiction. So science fiction is next. On the boys' science fiction, it says is 14. So let's see if I can make it look like 14. And then on the girls' science fiction is up at 20. So, like so. That's not a fabulous job on those, but you're getting the idea, I hope. Next is a biography. Biographies, the boys were up at 8. So I'm just going to go up to 8 on the boys. And then the girls were up at 17. So I draw my graph up there like that. Kind of a quick little rendition of a bar graph here for you. And then the very last one is other. The boys are at 5. And the girls are at 3. So even smaller than that one. And then that would just be a great example of how to do a bar graph for that. Again, like I said, you could have chose to do a line graph. We could have chose to count by a different number than 5 there. Maybe by 3s would have been better. It would have made it easier to draw our bar graphs. We could go, and we probably should label like I did here, boys and girls, and make it look so, so the yellow is always boys, and then the green is always girls, and you could label that so it made more sense as you're doing it. But that's a great example of what a bar graph should look like from a set of data. So this is what we're doing today, you guys. We're doing all sorts of stuff with analyzing graphs and drawing them on our own. Thanks for watching, and good luck with your assignment.